Join us for an in-depth exploration of the flat Earth theory and the geocentric model of the universe. Surely you've heard about Ptolemy and his theories regarding the flat Earth, but did you know he had some opponents too? And what about Columbus, Marco Polo, and Magellan? When they embarked on those famous journeys and adventures, what did they believe about the Earth? Was it a sphere or was it a disk? Stay with me to find out. Don't forget to show your support by giving this video a thumbs up and leaving a comment down below. Now let's get started.
Throughout history, humanity has grappled with understanding the cosmos and our place within it. One of the most enduring debates revolves around the shape of the Earth and the structure of the universe. From ancient civilizations to the Renaissance, various theories and models have been proposed, challenged, and refined, leading to significant shifts in our understanding of cosmology. The heart of this exploration is Claudius Ptolemy, a towering figure in ancient astronomy. Ptolemy's work, Almagest, compiled in the 2nd century AD, presented a comprehensive treatise on the geocentric model of the universe. In Ptolemy's cosmology, the Earth was considered the stationary center of the universe, around which the sun, moon, planets, and stars orbited in perfectly circular paths. This model was heavily influenced by the philosophical and scientific traditions of ancient Greece, particularly the works of Aristotle and Hipparchus. Ptolemy's geocentric model held sway for centuries, but it was not without its detractors. One notable opponent was Aristarchus of Samos, who proposed a heliocentric model of the universe, with the sun at the center and the Earth revolving around it. However, Aristarchus's revolutionary ideas were largely ignored during his time, and Ptolemy's geocentric model remained dominant. The Roman era saw the adoption and further development of Ptolemaic cosmology. Roman astronomers such as Geminus contributed to the refinement of astronomical theories and observations, solidifying the geocentric view of the universe in Western thought. Before the Roman era and the time of Marco Polo, several ancient civilizations and thinkers demonstrated that the Earth is a sphere through various methods and observations. One of the earliest recorded instances of this realization dates back to ancient Greece. Eratosthenes, a Greek mathematician, astronomer, and geographer who lived in the 3rd century BC, is perhaps best known for his calculation of the Earth's circumference. By measuring the angle of the sun's rays at 2 different locations on Earth, Alexandria and Siena, and knowing the distance between them, Eratosthenes was able to estimate the Earth's size with remarkable accuracy. His method demonstrated that the Earth's surface is curved, indicating a spherical shape. While not providing direct empirical evidence, the Greek philosopher Pythagoras, circa 6th century BC, and his followers proposed that the Earth was a sphere based on philosophical reasoning and observations of celestial phenomena. Pythagoras believed in the harmony of the spheres and argued that the most perfect shape for celestial bodies, including the Earth, was a sphere. The ancient Greek philosopher Aristotle, circa 4th century BC, also supported the idea of a spherical Earth. In his work On the Heavens, Aristotle observed the curved shadow of the Earth during a lunar eclipse and deduced that the Earth's shape must be spherical. He also noted that different constellations could be seen at different latitudes, further supporting the idea of a curved Earth. Fast forward to the Age of Exploration, and we encounter figures like Marco Polo, Christopher Columbus, and Ferdinand Magellan. Despite living in an era of expanding knowledge and exploration, these individuals were already aware of the spherical nature of the Earth. Polo's travels in the 13th century provided first-hand evidence of Earth's curvature, while Columbus and Magellan embarked on voyages that further confirmed this understanding. However, it was during the Renaissance that the foundations of modern cosmology were laid. Visionaries like Galileo Galilei, Giordano Bruno, and Nicolaus Copernicus challenged the entrenched dogma of Ptolemaic astronomy. Giordano Bruno, born in 1548 in Italy, was a philosopher, mathematician, and cosmologist ahead of his time. Bruno proposed an infinite universe filled with countless worlds, challenging the anthropocentric view of creation. He advocated for a heliocentric model of the universe, asserting that the Earth was not the center of the cosmos. Bruno's radical ideas brought him into conflict with religious authorities, leading to his condemnation for heresy. In 1600, he was burned at the stake, a martyr for the pursuit of knowledge and the freedom of thought. Galileo Galilei, born in 1564 in Italy, was a polymath renowned for his contributions to astronomy, physics, and mathematics. He improved the telescope, enabling him to make groundbreaking observations that supported the heliocentric model proposed by Copernicus. Galileo's discoveries, including the phases of Venus and the moons of Jupiter, provided empirical evidence for heliocentrism. Despite his scientific achievements, Galileo faced vehement opposition from the Catholic Church, which saw his support for heliocentrism as heretical. He was tried by the Inquisition, forced to recant his views, and spent the rest of his life under house arrest. Nicholas Copernicus, born in 1473 in Poland, was a Renaissance mathematician and astronomer. His seminal work, De Revolutionibus Orbium Coelestium, presented the heliocentric model of the universe. Copernicus proposed that the Sun, rather than the Earth, was at the center of the cosmos, with the planets orbiting around it. His heliocentric model challenged the geocentric view upheld by religious and scientific authorities. Although Copernicus faced criticism during his lifetime, his ideas laid the groundwork for modern astronomy. The discoveries of Galileo, Bruno, and Copernicus were met with fierce opposition from religious institutions, particularly the Roman Catholic Church. The Church saw their heliocentric views as threats to religious doctrine and authority, leading to censorship, condemnation, and persecution. Fine. Until now, we saw that the Catholic Church was the biggest enemy of the heliocentrism. However, eventually, who convinced this organization that the Earth is not the center of the universe? Well, this person was a German man named Johannes Kepler. Kepler was born on December 27, 1571, in Weil der Stadt, in what is now Germany. He showed an early aptitude for mathematics and astronomy and pursued higher education in these fields. Kepler studied at the University of Tübingen, where he excelled in mathematics and received a Lutheran scholarship to continue his studies. Kepler's contributions were certainly crucial in providing a mathematical framework for heliocentrism through his laws of planetary motion and in advocating for a reconciliation between scientific discoveries and religious beliefs. However, the acceptance of heliocentrism was a complex process that involved the cumulative efforts of multiple individuals over several centuries. He formulated 3 laws of planetary motion, which provided a mathematical framework for understanding the motion of celestial bodies in a heliocentric system. Kepler's laws replaced the complex and inaccurate system of epicycles and deference proposed by Ptolemy and refined by Copernicus. Kepler's laws were based on empirical observations and rigorous mathematical analysis, making them difficult to refute. Unlike Galileo, Kepler sought to reconcile his scientific discoveries with religious beliefs, particularly those of the Catholic Church. Kepler argued that the heliocentric model of the universe did not necessarily contradict the Bible's teachings, but rather offered a deeper understanding of God's creation. His efforts to bridge the gap between science and religion helped to alleviate some of the Church's concerns about heliocentrism. While Kepler's work played a significant role in advancing heliocentrism and gaining acceptance within the scientific community, it was not until much later that the Catholic Church officially recognized the heliocentric model. In 1822, the Catholic Church removed Galileo's works from the Index of Forbidden Books, signalling a tacit acceptance of heliocentrism. Finally, in 1992, Pope John Paul II officially acknowledged that the Church had erred in condemning Galileo, acknowledging the validity of heliocentrism as a scientific theory. Now that we've explored how our understanding of the world has evolved over history, let's shift our focus to the planets in our solar system. How many years have we known about them? Known since ancient times, Mercury was observed by numerous civilizations, including the Babylonians, Greeks, and Egyptians. Its visibility to the naked eye allowed for its recognition as a planet long before the advent of telescopes. Similarly, Venus has been known since ancient times due to its bright appearance in the sky. Early astronomers, such as the Babylonians and Greeks, observed and recorded its movements. Mars, often referred to as the Red Planet, has been observed for millennia. Ancient civilizations, including the Babylonians and Egyptians, documented its motion across the night sky. Jupiter, the largest planet in our solar system, has been known since ancient times. It was observed by civilizations such as the Babylonians and Greeks, who recorded its movements among the stars. Saturn's discovery is attributed to ancient civilizations, including the Babylonians and Greeks. Its distinctive rings were first observed by Galileo Galilei in 1610 through his telescope. Uranus was the first planet to be discovered using a telescope. It was first observed by the British astronomer Sir William Herschel on March 13, 1781. Neptune's discovery is credited to the French mathematician Urbain Le Verrier and the British astronomer John Couch Adams. Based on mathematical calculations, Le Verrier predicted the existence and position of Neptune in 1846, leading to its subsequent observation. Pluto was discovered by the American astronomer Clyde Tombaugh on February 18, 1930. Tombaugh's discovery was made through a systematic search for a ninth planet beyond Neptune. At the end of this video, I encourage you to share your thoughts by leaving a comment below and giving us a thumbs up if you enjoyed the content. Your feedback helps us improve and bring you more of the videos you love. Thank you for watching. This is ATC History.